Okay, this problem says find the values of the 6 trig functions down here for angle theta in standard position if a point here with the given coordinates lies on its terminal side. All right, so this is a bit tricky, but once we do one, I think we get the hang of it. So let's look at this point right here, -4, 4. I'll do it maybe in the middle. -4, 4. If you think of an XY plane, -4, 4 is going to be back 4 and up 4. Right? It's as far back as it is up. Hopefully I drew that about right. 4, 4. So if we drop an altitude down and then create a right triangle like this, this is my right angle. This is the theta we're looking to solve for. And this is -4 and 4. Let's see, we have -4, we went back 4, so this is -4, like that on our coordinate plane. And also we went up 4, like this. So back 4 and up 4. So we need to solve for these using our fractions that we're going to get from our right triangle. Right, now I can do a couple of them right now, but I need the hypotenuse to really make this happen. And to do that, we're going to think of this in terms of distance. All right, so it's a little bit tricky. Some of these negatives aren't always going to be true negatives because it's distance with a triangle. But think of this for a second. If we take -4 squared plus 4 squared, right? A squared plus b squared, this should equal our c squared right in there. So let's try that. Equals c squared, or hypotenuse. -4 squared is 16, so is 4 squared, and it's going to equal c squared. 16 plus 16 is 32, which is c squared. If I take the square root of both sides, that's going to give me c over here, which is good. Then the square root of 32 can be simplified. Remember, this the biggest square root that goes into that, since we put 16 in there twice, is going to be 16 times 2, or the square root of 16 times the square root of 2. The square root of 16, of course, is 4, or this is 4 square roots of 2. All right, so 4 square roots of 2. Some of you might remember that from geometry, where we have 45, 45, 90 right triangle. This is just going to be the side length and then the square root of 2. All right, so that's how you find the hypotenuse. Now, once we have that, we can figure out the rest of our fractions using sine, cosine, tangent, cosecant, secant, and cotangent. So sine of theta, sine is opposite over hypotenuse, is going to equal 4 over 4 square roots of 2. So our 4's cancel. This is going to be 1 over the square root of 2. But of course, we cannot have a square root in the denominator, so I have to rationalize it. And this will give me the square root of 2 over 2 for sine of theta. All right, cosine of theta is similar. Cosine here, we're going to have -4 over 4 square roots of 2, adjacent over our hypotenuse. So again, it's going to be -1 this time over the square root of 2. Rationalize your denominator, and that gives us negative square root of 2 over 2. All right, tangent of theta is just going to be, compared to theta, tangent is opposite over adjacent, or 4 over -4, which is -1. That one simplifies nicely. What about cosecant? Cosecant, if you remember, is just going to be sine flipped. Now, you can go back to a previous, these all equal each other, right? These all equal each other. So you can go back to a previous version right here and just flip that to make this nice and easy. And this is the square root of 2 over 1, if I flip it, or just the square root of 2. Okay? And I could get there if I flip this one. Here, I'll just show you really quick. If I bring it out and do 2, if I flip it, 2 over the square root of 2, rationalize the denominator, and we get 2 square roots of 2 over 2. Those cancel, which is just the square root of 2. Or you can kind of think back to what did I have before. It might make it an easy flip when I flip those. Same thing with secant. Again, back here, if I think of this as flipped, so now it's the square root of 2 over -1. Well, anything divided by -1 just makes it negative, so this is going to be negative square root of 2. And then lastly, cotangent. Well, -4 over +4 is still -1, so that one stays -1, both cotangent and tangent. And therefore we solved all 6, 1, 2, 3, 4, 5, 6 of our trig functions given our point -4, 4.